All right, well, thanks everybody for coming today. I'm going to provide an overview, so we'll cover a bunch of topics here. The overall theme of kind of water supply and availability within the Big Sky area. So just to start with kind of a broad scale view of kind of watershed hydrologic processes, you have your precipitation in the form of rain and snow leading to surface runoff that fills the rivers and the streams. You have some of that groundwater going into the groundwater through infiltration. You have evapotranspiration. And you have some of this water being used for municipal use, and you have stormwater runoff. So looking at water accumulation and snow in the Big Sky area, we have the Lone Mountain Snowtail site is the most kind of relevant data source. This has been around since 1992. It's a high elevation site sitting up there on the side of Lone Peak at 8,800 feet. I'm just looking at this data real quick, plotted between 1992 and 2015. The blue bars show kind of your annual accumulation, and this is based on the water year, starting from October 1, going through the year. And you see kind of in this time frame, kind of variability with overall annual water accumulation, maybe some higher years there in the 90s. You guys remember, 96, 97, some good consistent snow years. See some lower years kind of in the early 2000s in the middle of the graph there. You guys remember the drought years then. And then more recently, good runoffs and good snowpacks in 2011 and 2014. So with an overall range kind of from 26 to 42 or 43 inches, a mean annual accumulation of 33.7 inches. Along the top of this graph, you see the kind of the mean annual temperature being recorded at this snowtail site. You see kind of a little bit cooler there on the left in the early mid-90s. You see a warming trend as we progress towards the more recent end on the right side of the graph. Most recently, it was 38 degrees Fahrenheit as an average temperature, and that's the highest one is 2015 over the period of record. And then just looking at this year to see kind of where we're at, we were at 30.9 inches as of yesterday. We got a couple more days, so we get a little more rain. We might go above that, but so you could say we're a little bit below the annual average for this year. Looking at stream flow on the Gallatin River at the Gateway Gauge, which is kind of at the mouth of the canyon there, downstream of Spanish Creek. It's a snow melt dominated runoff, as you all know, with peaks in June, as you see there. Base flow periods kind of December through March. I wanted to just show here, between the 1930s and 2010s, there's annual variability, and there's more variability kind of in those high water, during May and June. So for example, the lower runoffs that you see in the 30s and the 80s and the 2000s, you see higher runoffs in the 70s, the 60s, the 70s, and the 90s. So it's more variable during the peak flows, and that's when most of the water is supplied. Honing in on what might be happening kind of as a trend, looking at, the first 65 years of record here at the Gallatin Gauge, 1930 to 1995, versus what's occurred in green in the 1996 to 2015 in the last 20 years. It's a pretty simple data analysis, but I'd like to point out that perhaps you see in May and June, more water coming out during runoff. And then as you look in August and September and October, that green bar is a little bit lower for the last 20 years. So perhaps we're seeing lower late season flows. Specifically to the West Fork Gallatin River watershed, we've done some monitoring. This is data from 2005 to 2008 on the West Fork, 2006 to 2008 time frame. We had gauges on the North Fork, the South Fork, Upper West Fork, and Lower West Fork. You can see these kind of plotted here on this map. And then the DNRC also monitored above and below the West Fork. Here you've seen those darker orange dots in that same similar time frame. So, the North Fork is the lowest one in green there, kind of a late peak, but a low steady runoff in July. The Upper West Fork, which would be the North Fork and the Middle Fork combined, peaking earlier there. The South Fork, West Fork kind of peaking later and driving the peak of the main stem of the West Fork, which is that lowest site in purple. You can see the Gallatin was, 6,000 CFS per peak on June 23rd of this year. This is 2008's data. So, you know, if 1,000 CFS is coming out of the West Fork, then there's 6,000 CFS getting, you know, generated at the main stem. Looking at just low flows in the same time period, I'll maybe go kind of quick here, but the North Fork at 4 CFS in September, the Middle Fork at 4 CFS, the Upper West Fork at 8, South Fork at 9, and total CFS of, you know, an average of 18 coming out of the watershed at low flow during the 2006 and 8 period. Looking at the DNRC data, kind of bracketing the upstream and downstream ends, or above and below the West Fork, we see above the West Fork in blue there, when you add the two together, you have the orange line, and then downstream you get this giant jump in that green line, and there's a lot of groundwater upwelling coming in there as the valley narrows and the water is pushed up there, in the range of, you know, 50 to 120 CFS and averaging 86. And these are some of these springs that you see along the highway there, and some of that water is coming from these springs, and some of it is probably just coming up through the riverbed. So looking at water supply for the Big Sky area, kind of look at it as 4 distinct service areas. The areas that are served by Big Sky Sewer and Water District, which is the resort, Spanish Peaks and Town Center, the Lone Mountain Land Company, and Moonlight Basin, the Yellowstone Club area, and then the Canyon area, which is along the Gallatin River. You know, looking at these areas on the maps, kind of zoomed in on the ownership boundaries, but you see the various ownerships, and you see the Sewer and Water District kind of laid on top of that with the orange bracket. So it doesn't really cover, you know, a pretty broad area. So there's a bunch of different activities going on in these other areas. Focusing in on the Water and Sewer District, in orange here, you see their wells in the meadow on the right side there of the slide, kind of where we're at right here, and they also have a series of wells up in the Mountain Village area. Just looking at overall kind of water production, in their Meadow Village wells, there are 5 wells, 7 in the Mountain Village, Spanish Peaks and Moonlight have their own wells, total kind of production of 350 million gallons per year. Just looking at water production kind of in a summer versus winter use. I mean, most of the use of the water occurs in the summer for the Water and Sewer District. For future water demand here, kind of the top 2 lines are, you know, the Mountain and Meadow wells and gallons per minute. You can see on the left, 2015, what the kind of usage right now is, and, you know, projected water demand increasing over the next 25 years. So just look at how, you know, impact of development on this water supply. As you increase your impervious amount of surface cover, you originally start with a little bit amount of runoff on the top left there, a lot of evapotranspiration and a lot of infiltration. As you increase your amount of impervious surfaces, you move to the bottom right, you have, you know, a dramatic increase in surface runoff, slightly less evapotranspiration, and a lot less infiltration. So now looking at the impact of climate variability on water supply, this, you know, graph of historic kind of snow water equivalent at the start of April indicates that we've lost approximately 20% less water sitting in the mountains come April 1 than the long-term average, with temperature being the primary driver here. And while this is for the greater Yellowstone region, the Gallatin River in itself mimics kind of what you see here. Looking at the kind of the upper Missouri Basin, just a long-term stream flow, kind of our focus areas of that red circle there. You see small red triangles that are pointing down. That just indicates that we have lower stream flows over the last 50 years, generally speaking, throughout the basin. The regional models here, you have 4 different models. You have temperature on the left, precip on the right. Just to look real quickly on the left, you know, they all indicate increased temperatures that are occurring. On the precipitation on the right, the models kind of indicate, you know, precipitation might be going up by up to 50%, it might be going down by, you know, 5%, so more variable. In the Northern Rockies, just looking forward to the future, right now we're in a snow kind of system. In the 2040s, we're still predicted to be snow there in blue, but by the 2080s, we're predicted to be in this transitional zone. We've seen lots of, you know, increase in temperatures, predicting earlier snow melts, greater amounts of precipitation in the form of rain than in snow, and potentially lower stream flows in the summer. So we got a couple last slides here, but if I'm out of time. For water resources, you know, you got to plan for uncertainty. There's going to be a lot of change, potentially, and that management strategies, you know, would include storage, you know, water conservation, and other infrastructure and management type activities. With that, I'll pass the baton.
Thank you.